Hello, I'm Morgan Scheuerman, and I'm going to talk to you about the work that colleagues and I did at University of Colorado Boulder on how race and gender are constructed in computer vision databases. We all experience the visible external features associated with race and gender when we interact with the world. As a result of these interactions, we also hold our own affinities with race, gender, and a multitude of other identities. Race and gender have also always been incorporated into technical systems. From the US Census to Facebook, we see technical representations of these identities everywhere. They have also become increasingly embedded into databases used to train machine learning-based algorithms. Perhaps the most salient example of this is in facial analysis technology. Within the last decade, facial analysis technology has quickly transitioned from a theoretical research problem to a commercial reality. Facial analysis technology is already widely used. For example, it is employed by law enforcement, or it's used to track consumer behavior and demographics inside of stores. The outputs produced by facial analysis systems are premised on their training and evaluation data. The image is used to teach the system what a subject looks like. We analyzed how race and gender are represented in image databases and how those representations are derived. What categories are employed to represent race and gender? What sources are being used to derive race and gender labels? How are database authors describing the annotation procedures for race and gender categories? To answer these questions, we took a socio-historical approach in our analysis. Historically, formally classifying race and gender has also resulted in harm. For example, the differential access to healthcare for marginalized genders and the targeted extermination of racial groups. We analyzed race and gender in training databases from a critical discursive perspective. Specifically, we investigated how race and gender were codified into 92 image databases, many of which are publicly accessible and widely used in computer vision research. We saw vast inconsistencies across racial categories and methods for determining the race of a person in image data, with some databases employing 3 racial categories, like Microsoft's Celeb 1 million, and others employing 7, like 10K US adult faces. We also saw historically problematic categories for race that would often be viewed as inappropriate. Meanwhile, as previously documented in our own prior work, we found consistently binary categories for gender. We saw different forms of this binary, such as M versus F in the AR database, or male versus attractive woman in PubVig. At the same time, we found that the majority of image databases rarely contained any kind of underlying source or reference for how those identities are defined. Further, when images are annotated with race and gender information, database authors rarely describe the process of annotation, such as who is doing the annotating and what visual cues are leading them to make specific judgments. The lack of transparency around race and gender made it difficult, if not impossible, for outsiders to understand how identity-based decisions are being made when constructing these databases. And such constructions are important. Categories of race and gender have been socio-historically linked to politics of oppression. Race classifications in the United States have determined every aspect of a person's life. Gender classifications have determined who can get access to certain spaces in healthcare. Such examples of older technologies of classification are portable to new facial analysis technologies. We posit that the lack of similar engagement with ground truth race and gender data undermine the very purpose of image databases to be usable, reliable, and accurate. Further, it ignores the socio-historical reality of race and gender. We thus observed race and gender categories that are socially and historically complex, portrayed as obvious, static, and apolitical. In our paper, we discuss opportunities for improving the current state of image database construction and documentation. For example, by actively acknowledging the socio-historical context that databases stem from, we can attempt to avoid replicating the harms done by historical classification systems. By explicitly stating the limitations of use of this data, we can help protect marginalized groups which might otherwise be harmed by the deployment of facial analysis technologies. And by regularly revisiting and revising databases and retracting those that have been deemed harmful, we can prevent their further entrenchment into future systems. Thank you for listening, and feel free to reach out to me with any questions.